Bismillah Rahman Rahim. In the previous lecture, we discussed about general concept about quantum mechanics and classical mechanics. So the difference between these two mechanics. So today we will explore further about the some sort of the definition, and then we will move to the next lecture. So quantum mechanics basically is the science dealing with the behavior of the matter and light on the atomic and subatomic scale. So that means on the micro scale level, if we are dealing with the matter, this originates the study of the quantum mechanics. While with the classical mechanics, just as a differentiation, it is describing dealing with the motion of macroscopic objects, contrary to the quantum mechanics. So basically, we deal with the large parts of the machinery and macroscopic object, planets, stars, and galaxies. So all these come under the heading of the classical mechanics. So what actually we will study the quantum chemistry, and this is the actually the molecular quantum mechanics, and you can generally say the application of the quantum mechanics in chemistry and dealing with the actually the electronic structure and molecular dynamics. So this is all about the study of the quantum chemistry. So we will further explore how the molecules or the atoms uh, uh, are or what is happening inside with the electronic structure and their dynamics with the interaction of radiation or the light with the matter. So this is our first the proper topic on the wave theory of light. So I am just going to describe very general knowledge which might you have already before, but these are very important to learn because are going to apply this knowledge to understand the future lecture as well. So let's suppose this is the actually the wave passing through this point, and this is the amplitude of the wave, and from these are called the nodes where the energy of the wave is zero at in a specific axis. So these are called the nodes, and the distance between these two nodes, it is called the wavelength. So this is called one wavelength, and this wavelength may vary. Sometimes we have the smaller wavelength, we have the larger wavelength like here, and the upper side is called the crest and the lower side is called the trough. We call it the positive, minus. Now the next is what is the frequency. So frequency is the number of wave passing through a certain point. So let's suppose this is the wave, and this wave is passing through maybe this point or this point. How many waves are passing through this point in a specific time? That is called the frequency. Let's suppose 12 waves are passing through a certain point in 30 seconds. So what will be the frequency? 12 waves per 30 seconds. So the frequency is 0.40 per second. That means 0.40 wave per second. And generally it is called the hertz. It is the name of the scientist. So if you look at this one, actually frequency is per time. So this is to remember the number of waves passing through a certain point in a specific time. It is called the frequency. So frequency, the unit is per second. So that means if I want to convert into the second, so second will be per frequency. So let's suppose if I divide one by frequency and one by per second, this per second will become second and this will be the per frequency. Why I'm going to use to describe this one? Because I am going to apply this knowledge to calculate the speed of the light. So speed generally is the distance traveled per time elapsed. So distance traveled, this is the distance. That means the distance of the wave or the wavelength. This is called the distance traveled by a wave. And how many waves are passing in a unit time elapsed, and this is called the per frequency as I have described before. So lambda per frequency, and this will be, if you move up, that will become the frequency. So this is generally we show the speed with the c. So c will be equal to lambda mu. Actually, this c is coming from this formula. Here is an example to calculate the wavelength or the frequency or the speed of light. You can use this formula, like the example is given over here. Almost all commercially available microwave ovens use radiation with a frequency of 2.45 exponent 9 hertz. Calculate the wavelength of this radiation. So you can just put the values over here in this formula. Here see the speed of light, that means it is 3 exponent 8 meter per second, and frequency is this. When you calculate, it comes out with 0.122 meter, and this is the distance of the wave, or it is called the wavelength. You can further convert into the centimeter, or even you can put here 3 exponent 10 centimeter per second. It will directly give you the value 12.2 centimeter. Now the both wave, these are perpendicular to each other. If this is the magnetic field and this one is the electrical field, and both you can see here, both are perpendicular to each other because it is the component of electrical and magnetic field. That's why we call it the electromagnetic radiation. This is very important. Now, actually, this is the basics of the quantum mechanics. We are going to describe what is happening with the molecules or the atoms with the interaction of the radiation. And there are many forms of the electromagnetic radiation, starting with the gamma rays, X-ray, UV visible, IR, microwaves, and there are two forms of the radio waves, FM and AM, and further long radio waves. So if you have a look, the wavelength is going to increase from gamma rays to the radio waves, and this is the frequency is going to decrease from gamma rays to the radio waves, or the energy is also decreased from this to this side, because according to the Planck's equation is to h mu and E are proportional to each other. If mu is increasing this side or decreasing this side, that means it is the similarly you can explain the energy is increasing this side or decreasing this side. Actually, important is to understand this frequency or the energy are inversely proportional to the wavelength. So if the energy is more or the frequency is more, the wavelength will be small. So these are the different radiations. Now we are going to discuss here actually what the quantum chemistry or the quantum mechanics is going to help us to understand what is happening with the atoms uh, with respect to their electronic structure and their molecular dynamics, as we have discussed before in the previous slide. So actually, this is the happening because the molecules, why there are the different types of the radiation, because the molecule have different type of the motion. So basically, I am going to describe here actually why the different form of the EMRs, not only one form of the EMRs, why there are the different forms, and different forms due to the different motion of the molecules of the atoms. So let's start. These are the the fundamental or three major movement of the molecules. So one is the translational movement. That means moving to a specific direction. It is like so it is moving to the x direction or the y direction or the z direction. The whole molecule is moving. It is the translation motion. So if the molecule maybe is rotating along a axis, it is called the rotation. And the molecule may be the vibrate, and there are different movement of the vibration motion, and this is called the vibration motion. Here, this is the depiction in the picture. That means if moving something is moving in a direction, this is called the translation motion. It is moving in the it is rotating along the x-axis, that is called the rotational motion. And these are the two motion. If the molecules is going to the one direction by rotating, and you can say this is the rotational translational motion. And third one is the electronic transitions. These are very important, and this is happening with the transition of the electrons from the one state to the other state. We are not going to discuss detail over here. So similarly, you can say from, let's suppose the transition from the K to L shell or from L to M shell. And these transitions with respect to the electrons, that's why these are called the electronic transitions. And lastly, it is a vibrational motion, and the example is the oscillatory motion, like a pendulum. And here you can just see what is the vibration, because the molecule is not moving. It is this direction, and it will remain after vibration from A to C. And there are the different types of the vibrational which originate the spectroscopy. Actually, why I have discussed all these vibration, because these vibration actually are the basic of the spectroscopy. And what is the spectroscopy? Spectroscopy measures the interaction of the molecules with electromagnetic radiation. So actually it measure what is going to measure, that means it is the spectra, and spectra is coming from the interaction of the electromagnetic radiation with the molecules of the atoms. And these interaction will be the different, they may lead to the electronic transition, they may lead to the translation motion, vibration motion, or rotational motion. So actually all these movement is happening inside, or are happening with the molecules. That's why they are going to originate different movements of the molecules. And that's why you have a different types of the spectroscopic techniques. So here again, if you have a look over here, this is the gamma rays having the energy, more energy than X-rays, UV, visible, IR, microwaves, and the radio waves. Here it is the heat, it is the actually the microwaves is here. So energy is increasing this side. This is having more energy, or this is having the less this is having more energy and more frequency, or it is having the less wavelength, because wavelength is inversely proportional to the energy, and the frequency according to the Planck's quantum theory is equal to hv. So let's see what is being originate with the interaction of the electromagnetic radiation with the matter. So the first one is the X-rays. So if you have a look on uh, the arrangement of the subatomic particle in atom, so these are the nucleus. Nucleus means neutron and the proton, and extranuclear part, there are the electrons. So electrons, there are the different shells, maybe the K shell, L shell, or the M shell. So what is happening with the X-rays? X-rays is the transition of the inner electrons. That means if the electron is coming out from the K shell, so it creates a vacancy in the K shell. So to fulfill this frequency, the electrons present in the L shell will move from the L to the K shell, and this excess of energy is going to release because the L shell electron having more energy as compared to the K shell. So this extra energy is released, that is called the X-rays. So X-rays are due to the transition of the inner electrons. Inner electron means the electron present in the K shell, and the spectroscopy originating through this X-ray is called the X-ray spectroscopy. Now, gamma ray are also helpful for the inner electronic transitions because actually gamma ray is the property of the nucleus because they are coming from the nucleus and the first interaction with the K shell. So when they interact with the K shell, they may remove the electrons from the K shell, and similarly, the process will happen. X-rays are going to emit, but gamma ray is another technique due to the energy difference in the nucleus, energy difference in the protons and the neutron, and this originate another spectroscopy that is called the MOSFET spectroscopy with the, or we call it the gamma ray spectroscopy. Now, if the there is the movement or the transition of the outermost electrons, that means electron present in the valence shells. So this is the basis of the spectroscopy that is called the UV visible spectroscopy. So UV visible if, spectroscopy are due to the transition of the electron from the outermost shell. So you can see why this is happening. This is only due to the difference in energy, or the difference in energy is due to the difference in the wavelength, as we have already described here, because all three components are related directly or indirectly or inversely related to each other. So when they are the outer shell transition, this originates the two type of the spectroscopy. One is the UV visible spectroscopy, or we call the ultraviolet spectroscopy, or the visible spectroscopy. Another spectroscopy is the atomic absorption spectroscopy, because this is also with the transition of the electrons or the transition of the atoms as well. If now this we have discussed gamma rays, X-ray, UV visible, now IR. If IR is the due to the movement of the vibrational movement of the molecules, if the molecules the atoms the present in the molecules are vibrating, then the energy which is responsible for this vibrational motion is called the infrared, and the spectroscopy due to this one is called the infrared spectroscopy. And now the other is left. If there is the rotational motion, rotational motion is due to the microwave radiation, electromagnetic radiation, and this is the sometimes we call it the scattering of light, and the spectroscopy due to the molecular rotation or due to the microwaves, and this is called the Raman spectroscopy. And lastly, it is the radio waves. Radio waves is responsible for the nuclear spin, and nuclear spin, the technique of the spectroscopy is called the nuclear magnetic resonance spectroscopy. So this is all about the originate of the spectroscopic techniques with the interaction of radiation with the matters. Actually, the quantum chemistry or the quantum mechanics is going to help us to understand what is happening with the interaction of the radiation with the molecules or the atoms, and why there is a variety of the spectroscopic technique. And this variety of the spectroscopy technique actually due to the different movement of the molecules or the atoms or the electrons present in the inner shells or the outer shells, or due to the energy difference of the nucleus, due to the energy difference of the neutron and the proton. So this is all about the spectroscopy techniques.